Okay, so the next piece of basic Python functionality I'll discuss are conditionals. And conditionals help you control the flow of your script by basically setting rules for whether certain parts of the code will be executed or not. And these work pretty similar to certain Grasshopper functions like dispatches or call patterns, where you actually use trues and falses and different Boolean operations to trigger specific functions. In the script, this functionality is much more flexible because we can actually write out specifically the conditionals that we want to use. So the basic syntax for a conditional is sort of like you're asking a question. So you're basically saying if something is true, colon, and then you hit enter, you see that Python will automatically indent your line. And once you're in this indent, it basically means that this is a sub chunk of code, and that code will only run if this conditional ends up being correct. So if we have a Boolean called something and it's true, and then we say if something is true, then we'll execute this code and we'll print it's true. So we'll test that. So you can see here it's printed our string because that something happened to be true. Now if we declare that something is false, now what happens is it tests this condition and turns out that this isn't correct, so it'll just skip over that print statement. So when we test it now, you see that that never prints. As a shortcut, if you want to test if something is true, you can actually leave out the true and just say if something, and that will work exactly the same way. And this is part of the appeal of Python, is that it's really user-friendly and it really tries to model as much as possible based on human language. So instead of being explicit about something being true, you can say, is this something? And then it'll control whether that gets executed. So basically, as long as you're in this indent, anything you type will be part of that condition, and anything you type after the indent, so here if we just delete that indent, then this will be executed regardless of this condition in the basic flow of the program. So if we change this again to false, this will get executed even though this statement is false. So in Python, it's very important to keep track of your indents, but it'll try to help you automatically to make sure you have the right ones. Okay, so in addition to testing if something's true, we can also execute specific lines of code if something doesn't pass the conditional. And for that, we use the else syntax. So right after the print statement, we can get rid of these indents and type else, colon, and see it indents again. We can print the alternate message. And you can see what happened here. Since something was false, it tested if that was correct. Since it wasn't, it skipped over this chunk of code and then executed whatever was in the else. So else basically executes if this does not pass. Okay? And in addition to that, we can also stack multiple conditionals. And for that, we use the elif. So this is a short for else if. And here we can basically daisy chain multiple conditions. So what this does is basically says if something, if that doesn't pass, it'll go on to this statement and it'll test that, and you can have any number of substatements. And then if all of those don't pass, then it'll execute else. So here we'll make another variable called something else, make that true. And after the else if, we again declare a test. So say else if something else is true, colon, and now we have another indent, another subset of code. Here we'll print another print statement and hit test. Okay, so in this case it printed our second string because it failed this condition, it went on to the next condition, and else if that was true. Now if this is false, it's going to again print our else statement because both of these didn't pass. And finally, you can also group multiple conditions in one statement by using the and or logic gates. And this is similar to what you would see in working with Booleans in Grasshopper. We can basically within one conditional statement say if something or something else, and we just use these keywords. You can see they turn like a light green color. So now if either of these statements is true, it'll print it's true. Right now it's false, but if I change this to true here, then that will get executed. And just like or, you can use and to test whether both things are true or not. Okay, so that's conditionals, and conditionals are a really useful, kind of crucial way that you can have control over the way that your scripts are executed. So by default, everything will be executed line by line. If you want to skip over a specific piece of code or do specific things based on a condition in your data, you really need to use conditionals. So the third basic piece of structure that I'm going to talk about in Python is loops, and loops are a way you can actually execute the same piece of code multiple times according to what you want your program to do. So the syntax of a loop is also very simple. You basically use the code word for, and after for you type in a variable, and this variable will take on new values as it's going through your loop, and then you say in, and then you give it a set of data. The way that loops work is pretty flexible in Python, but the basic structure is you give it some set of data or a list of values, and then you iterate over each of those values, and at each iteration a new value will be assigned to this I variable. So it doesn't have to be I, but I is a standard variable that's used and stands for iteration. Okay, so this is the basic structure. You end it with a colon just like any other operation, and here it's indent again, and this is to tell you that there's a subset of code that will execute according to this loop condition. So in order to make this work, we need to pass some set of data. To start off with, we can just make our own list. So we'll make set of data be a list, and here we'll just pass in a few integers. So now in this loop, it's going to basically go through each one of those 4 integers, assign a new integer to this I every time, and then execute this bit of code. So in this code you can put anything. Since there's 4 integers, this is going to run 4 times. You can just have it print something to start off with. You see here it's going to print that 4 times because it's executed this 4 times. But a really powerful feature of this is that you can actually reference this I while the code is running. So here I'll say print looping, and then I'll actually concatenate that string with the current number that I'm referencing from the list. So here I pass in I, which will be one of these integers. I wrap it in a string function. This will convert that integer into a string, so then I can add it to this looping string. So what this should do is each time iterate through this list, assign a new value to this I, and then print out which number I'm iterating. So this is a good way of going through a whole list and performing certain operations on every element of that list. And this is pretty similar to how also nodes work within Grasshopper, where if you pass a list of information, say, to the add node, it's going to do that add operation to every piece of that list. But just like with everything else, when it's in the script, it's a lot more specific, and you have a lot more control over specifically what happens and in what order. One common way to do this is, instead of just passing a set of data and assigning I to that piece of data every time, a lot of times we want I to actually be a count, or a counter of which position we are on the list. And for this, a typical way to do this is to combine the range and length functions in Python. In order to get the length of a list in Python, we can use the len command, and into this command we'll pass in our list, in this case set of data, and we can print that to see what happens. So here it's printed out 4 because there's 4 items in that list. And then we can also combine that with the range command. So if we wrap all of that in range, so into range now we're passing the length of the data, which is 4. Range will create a list of every integer starting from 1 up to this number. Okay, so if we print that range, you see what we get is a list starting from 0, 1, 2, and 3. And this is a typical way to set up loops, because instead of taking every piece of data here, we're just going to assign this I to count from 0 up until the end of our loop. So we can do the same thing here. We'll just pass this range function into our loop. So this is no different. Basically now this range is a list of items, but those items happen to be a counter for where we are in the loop. And then we can do something similar here. If we print I, it'll just print out that count. We can also use I to reference things within a list. So we can do the same thing as before, where we're printing out each piece of this list just by referencing that list, and then again using the square bracket notation to access a specific value. And since I is counting up from 0 to the end of our data, it's going to reference each one of these in turn. And it's really useful to do it this way because you can now reference multiple lists, and I will just keep track of which iteration you're on. So that's a really basic loop. We're going to use that like 90% of the time. Another basic kind of loop that sometimes comes in useful is the while loop. And while it performs similarly, it will basically perform a certain piece of code until a certain condition is met. And this kind of combines looping with conditionals. We'll just create a new variable, say while num is smaller than 10, and then colon. So you can see again the colon syntax, it indents, and that's going to run this chunk of code until num is no longer smaller than 10. So in order to make this work, first we have to initiate num with a certain value, right? Or else it's not going to know what this num is. So here we'll set num equal to 0 to start off with, and instead of while num is smaller than 10, execute this piece of code. So while loops come in really useful, but they're also really dangerous because if you don't build into your code a way for it to break out of this while loop, it will basically run forever and crash your program. So it's really important that somewhere within your while loop you actually have a condition or a way for this number to get bigger than 10 and thus exit out of the loop. So to do that, we'll just start to increase the value of num each time it runs the loop. So we'll just do num, and then we can say equals num plus 1. Okay, so here we're assigning num to itself plus 1. This will basically increase the number each time, and then we'll just print num to keep track of what's happening. If we hit test, you can see it's run through the loop 10 times, and each time starting with 0, it added 1, printed 1, and then the next time num is now 1, it's less than 10, so it passes condition, executes again until it's 9, at which point it adds 1, now it's 10, it prints it. When it goes back, 10 is no longer smaller than 10, so it just exits out of the loop. Okay, so those are the two basic kinds of loops, and we can use these to gain further control over the flow of our script and change both which statements gets executed and how many times those statements are run.